Now let's take a look at how to actually graph a linear inequality. So when we go to do the graphing part, right, we have to really start with the boundary line. And there's two ways we can approach that. We can get the inequality into y equals mx plus b form, our classic slope-intercept form, and then identify the slope and the y-intercept. Remember, the slope is m, that's our constant rate of change, and the y-intercept is b. The other way you could graph your line, your boundary line, is to find the x and the y-intercepts. And then you can plot those as points. So it's really up to you, and it really sort of depends what sort of equation you're working with, or sorry, inequality, and then that's going to help you determine which of these methods is better. Now, if we have a less than or equal to or a greater than or equal to, we will be graphing a solid boundary line. And if it's just a less than or a greater than, it will be a dashed boundary line. So let's see this in action. Okay, let's look at problem number 1. We have y is less than or equal to 1/4 x minus 5. So when we consider the boundary line, remember this inequality is really becoming an equal sign. So this is the equation, y equals 1/4 x minus 5. That's what we're graphing. That's our boundary line. In this case, I have the slope, which is 1/4, and the y-intercept, which is -5. So I'm going to start at -5, and then 1/4 means to go up 1 and right 4. And I have a couple points. Because my inequality is less than or equal to, this is going to translate into a solid boundary line. So I'm going to go ahead and draw a solid line there. So far, so good. And as you can see, the boundary line has divided my plane, my coordinate plane, into two halves. We kind of have this upper half here and this lower half. So now we have to decide where to shade, because remember, we want all of the points where the y values are less than or equal to 1/4 x minus 5. On the boundary line, all of the y values are equal to 1/4 x minus 5. So to find the points that work, we're going to go back up to our steps here. We're going to pick an ordered pair. Now, the neat thing about this step is that you can pick any ordered pair that you want. And I always like to pick, if possible, the origin. So the origin is a great choice. The only time it doesn't work is if your line, your boundary line, actually goes through the origin. So there is a couple of instances where it doesn't work. So if we go to our line and we test the point 0, 0, which is right here, we are going to substitute x and y in for 0 in for both x and y. And as we can see, we end up with 0 is less than -5. That is false. And so that means that the area of the plane that we're going to shade is the area of the plane that does not contain the origin. So it would be this portion of the plane. If you want to be on the safe side, you can actually then pick a second point to make sure that you've shaded the correct area of the plane and get a true statement. So if I look, I have this point right here. This is the point 1, 2, 3, 4, 5. 1, 2, 3, 4. This is the point 5, -5. Oh, that's probably not a good choice because it's 1/4 x. Okay, there we go. Learning every day here. Let's pick 4, -5. Let's try that. 1, 2, 3, 4, 5. Okay, so let's try 4, -5. So is -5, our y, less than 1/4 times 4 minus 5? Negative 5 is less than 1 minus 5. Negative 5 is less than negative 4 is true. Very good. So that does make sense. And just so that you get a different perspective on this, I went ahead and I graphed this in Desmos. And I'm going to toggle it on. Right now, you can see I have typed the equation, or the inequality, excuse me, into Desmos. And I'm going to turn it on. And there you go. There is the shading, just like we saw it. And again, you can see the origin is not a point. And I'm going to go ahead and type our point for negative 5 into the plane. And you can see it appears in our shaded region. Great. Let's try a second one. So for this second problem, I set it up so that we could do the x and y intercept method of graphing. It is in standard form, and that's usually the easier method. Now sometimes, depending on the way your equation looks, when you go to divide and find your intercepts, you might not get a nice integer point, and then I would probably use slope intercept for it. So to find the intercepts for our boundary line, again, we're going to consider this an equation, not an inequality. And our x-intercept is when our y is 0. So that would mean 5x is equal to 10, and x is 2. So our x-intercept is 2. And our y-intercept is when our x is 0. So negative 2y is 10. And so our y-intercept is negative 5. Because, though, when we go back to our inequality, this ends up as a less than, we are going to go ahead and do a dashed boundary line. This time, it's like we have a left half and a right half of the plane rather than a top half and a bottom half. And again, this is just basically how the lines are graphed. Both of these lines have positive slope. They're increasing from left to right, but it just is, again, how it sort of appears in the plane. I guess there's like a top and bottom. Well, it's all how you look at it. So I'm going to pick the origin again. I'm going to substitute 0 in for x and y. Is 5 times 0 minus 2 times 0 less than 10. I wanted to make sure I had that correct. 0 minus 0 is less than 10. Yes, it is. There we go. Easy. So we are going to shade this portion of the plane. And once more, I'm going to pull up Desmos just so that you can see how that graphs. Going to turn off that, turn on Desmos, and there we have it. And then you can see our x and y intercepts on the boundary line here. And then we can see other points in the shading. We're going to be practicing this when we get back in the classroom, but I hope this was a helpful introduction to graphing linear inequalities.